obviously, the stomach is acidic, right? And one of the purposes of this gastric juice being acidic is to sterilize the food, right? To kill any of the bacteria that were on the food that we ingested. But the other thing that the acidic environment does is it denatures all the proteins that you ingest, right? And remember, denaturation means taking something that has 3 dimensions and turning it down into just a chain, right? Primary structure, from tertiary or quaternary structure to primary structure. You need to have that primary structure so you can get at the peptide bonds, right, to break down the amino acids. So the acidic environment of the stomach gives us a long polypeptide, primary structure. Now there are going to be 2 classes of enzymes that facilitate the digestion of proteins. There are going to be enzymes that break down internal peptide bonds, like this, and there are going to be enzymes that break down external peptide bonds, like these. Right? So you're either going to break the protein down from the middle, or you're going to break it down from the ends. Does that kind of make sense? Mm-hmm. So if you break it down from the middle, here, you still have a polypeptide, right? And so the enzyme that digests proteins is called a peptidase. If it digests from the middle, it's called an endopeptidase. And are there more than one kind of endopeptidase? Absolutely, right? Because these amino acids are different, right? Because the structure of these amino acids are different, we need lots of different kinds of endopeptidases to be able to break them down. But that's what it's doing, it's breaking down the middle. Now, can you absorb this? Probably not. Probably still too big. So what we need then are other endopeptidases, and in particular an exopeptidase, because what's an exopeptidase going to do from the outside, right? Exo from the outside, it's going to either come from the carboxylin and break that down right there and release a single amino acid, or it's going to come from the amino area here and release a single amino acid. Now, can this same exopeptidase work from both ends? Are the structures different on the 2 ends? Yeah. So probably not. So the same enzyme that can break from this end probably can't break it from this end, because this looks different than that. The affinities would be different, right? So we have aminopeptidases, which is a category of an exopeptidase that breaks it down from where? The amino end. So are there aminopeptidases that come through this? Absolutely. And then we have carboxypeptidases, which break it from the carboxylin here that do this. So it's kind of like the little Pac-Man guys just flipping off from the end here. Break it in the middle. The reason you break it in the middle, why would you break it in the middle first? You break it into 2 equal pieces. Make it smaller. What's that?
Like, it'll make it easier for the aminopeptidases and the carboxypeptidases.
Yeah, because there's more, right?
Yeah.
I mean, here, if we take a big 100 chain, 100 to 300 amino acids long and break it down into lots of them that are like 10 long, now we can work at more than just the 2 ends, right? We've got all the ends from each little piece that we broke down. It's that whole surface area thing again, right? It's opportunity for digestion. It's efficiency. It's much more efficient to break this up into little pieces first and then do it from the ends. Honestly, are you doing all of it at the same time? Yes. Sure. But the purpose of these, and pepsin is one of these, by the way. This happens in the stomach. It does this. By the time it gets in the small intestine where all this is, we've taken one big polypeptide, we've got lots of little tiny ones already. So that's kind of the rationale for that. Again, it's just kind of consistent with